Greetings! My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Hey there! Whether you're learning fractions for the first time or brushing up your skills, you're in the right place. In this video, we will explore ways to compare fractions, step by step, using real-world examples. Stick around until the end for a strategy that works every time. When we compare numbers in mathematics, we use words like greater than, less than, or equal to. Just like with whole numbers, we use symbols like these to show the results of a comparison. If Sam has 3 apples and Jordan has 5, we can see who has more. We write this as 3 is less than 5. Before we compare fractions, one thing must always be true. The wholes must be the same size. Imagine a small bag of cat food and a giant bag. Comparing fractions of those bags wouldn't make sense because the whole is different. 1/4 of the large bag may be more cat food than 1/2 of the small bag. So it's important that the size of the whole is the same. Now on to comparing fractions. We'll start with using basic relationships between parts and a whole. Imagine 2 slices of pizza. One slice is 1/2 of a pizza. The other is 1/4 of the same size pizza. Which one is bigger? Both of these fractions are unit fractions, a fraction with a numerator of 1, meaning one part of the whole. As the denominator increases and the pizza is cut into more slices, each slice gets smaller. So, 1 part out of 2, or 1/2, is greater than 1 part out of 4, or 1/4. The fewer the pieces, the larger each piece is. Let's try another. Suppose you ate 1/5 of a bag of chips, while your friend ate 1/8 of the same bag. Who ate more, and how do you know? The fractions 1/5 and 1/8 are both unit fractions. Since 1/5 slices are bigger than 1/8 slices, you ate more chips. When fractions have the same denominator, it means the wholes are split into the same number of parts. So, to compare, we just look at the numerators, the number of parts taken. 2 granola bars are each cut into 4 pieces. One kid eats 3/4 of a granola bar, while another eats 1/4. Which fraction is greater? Since the pieces are the same size, 3 parts out of 4 is more than 1 part out of 4. So, 3/4 is greater than 1/4. Try this one. During regulation basketball, each team has 5 players on the court at a time. One team has 2/5 of its players with red hair on the court, while the other team has 3/5 with red hair. Write a true math statement comparing the 2 fractions. How do you know it's true? 2/5 is less than 3/5. As the fractions have the same denominator, the parts are the same size. 2 is less than 3. Now, suppose we both eat 2 pieces from a chocolate bar, but mine is split into 3 parts, and yours is from a bar split into 5 parts. Who ate more? 2/3 is greater than 2/5, because fewer cuts means bigger chunks, just like with unit fractions. Here's another. 2 people ate parts of 2 identical chocolate bars. One person ate 3/10 and the other person ate 3/4. Write a true math statement comparing the 2 fractions. How do you know it's true? Though both ate 3 pieces, the chocolate bars were cut differently. The bar cut into 10 pieces has smaller slices than the bar cut into 4. Therefore, 3/10 is less than 3/4. Let's talk about benchmark fractions, like 0, 1/2, and 1. One way to compare fractions is to use what we know about benchmark fractions. If your water bottle is filled 2/3, you've got more than half. If it's filled to 1/5, you've got less than half. In this case, 2/3 is greater than 1/5. This is a great shortcut when comparing. Ask yourself, is it more or less than 1/2? As you get more comfortable, you can use other fractions as benchmarks too. Van and Christine have the same number of friends. Van has known 11/12 of his friends since elementary school. Christine has known 5/8 of her friends since elementary school. Who has more friends from elementary school? How do you know? 5/8 is just a bit more than 1/2. 11/12, on the other hand, is close to 1. Therefore, Van has more friends from elementary school than Christine. Sometimes using visual models like drawings and number lines can help us make sense of fraction comparisons. And that's not just okay, it's smart. Let's start with a simple one. Imagine 2 brownies, one cut into 4 pieces and the other into 8. One person eats 3/4, another eats 5/8. Write a math statement to compare the fractions and determine who ate more. If we draw it out, it's easier to compare. The brownie divided into 4 parts has 3 shaded. The one divided into 8 parts has 5 shaded. Even without doing any math, you can see 3/4 is more than 5/8. We write that like this. Remember, fractions live on number lines too. The closer a fraction is to 1, the greater its value. If 3/4 is here and 5/8 is just a bit to the left, you can see that 3/4 is greater. Let's look at another example, this time with mixed numbers. I have 2 cats, Ginger and Bulldozer. Ginger ate 2 1/3 cans of cat food. Bulldozer ate 1 3/4 cans. Who ate more? I will draw parallel number lines so I can represent Ginger and Bulldozer, and I can see which is greater. Both amounts are represented as mixed numbers, so I need to extend the number line beyond 1. For Ginger, we move to 2, then divide the space between 2 and 3 into 3 equal parts. We mark off 1/3 more for 2 1/3. For Bulldozer, we go to 1, divide the space between 1 and 2 into 4 equal parts, and move forward 3 parts to represent 1 3/4. Looking at the number lines, it's clear. Ginger ate more. Try this one. Moran has garden beds for his vegetables. He has 2 1/2 beds planted with cucumbers and 5/2 beds planted with onions. Write a math statement to represent the relationship. Did he plant more beds with cucumbers or onions? I will use a bar model to represent each veggie. For cucumbers, we draw 2 rectangles fully shaded. We also draw one that is divided into 2 equal parts with 1 part shaded to represent the fraction. For onions, we need enough rectangles to give us 5 portions, each of size 1/2. I draw 1 rectangle with 2 parts, then another rectangle with 2 parts. That is only 4 parts, so I need another rectangle with 2 parts. I shade in 5 of the parts. We can write this math statement, which means Moran planted the same amount of cucumbers as onions. Using parallel number lines, the first will represent cucumbers. I move to the 2, and then divide the section between 2 and 3 into 2 equal parts. I move to the right 1/2 to show the mixed number 2 1/2. Now for onions. I divide the section between 0 and 1 into 2 parts. I move to the 1 on the number line, meaning I moved 2 halves. I divide the section between 1 and 2 into 2 parts. Moving to the 2 means I moved 4 halves. Finally, I divide the section between 2 and 3 into 2 equal parts. I move to this mark representing 5 halves. Looking at the number lines, we can see that the amount of cucumbers is the same as the amount of onions. That's the power of visual models and number lines. They let us see what numbers mean. Sometimes pictures can make tricky comparisons crystal clear. So, next time you're stuck, draw it out. Want a surefire way to compare fractions? Once you are comfortable with using models and relationships, you can use an algorithmic strategy, changing both fractions to have the same denominator. When 2 fractions share a denominator, you're simply comparing how many pieces there are. Bigger numerator, bigger value. To do this, we use equivalent fractions. These are different-looking fractions that have the same value. For example, 1/2 and 2/4 represent the same amount. We create equivalent fractions by multiplying the numerator and the denominator by the same number. So if I take 1/2 and multiply the top and bottom by 2, I get 2/4. Let's look at an example. Two people have the same number of social media followers. For one person, 2/3 of their followers are family. For the other, 3/4 are family. Who has more family followers? To compare these, we'll rewrite both with the same denominator. Both 3 and 4 divide evenly into 12, so we can use it as a common denominator. Convert the 2/3 by multiplying the numerator and denominator by 4, giving us the equivalent fraction 8/12. We convert the 3/4 by multiplying its numerator and denominator by 3 for the equivalent fraction 9/12. Now that both have the same denominator, we simply compare the numerators. 9 is greater than 8, so 3/4 is greater than 2/3. That person has more family followers. Getting common denominators makes comparing them easy. Try this one. 2/5 of a field is planted with corn. 3/7 is planted with tomatoes. Is the statement 2/5 is greater than 3/7 true? Let's find a common denominator. The least common multiple of 5 and 7 is 35. To convert the 2/5, multiply by the fraction 7/7, giving us an equivalent fraction 14/35. To convert 3/7, multiply by 5/5. We get the equivalent fraction 15/35. Now compare the numerators. 15 is greater than 14, so the statement 2/5 is greater than 3/7 is false. Using common denominators is a powerful strategy. When models aren't practical, algorithms help you compare quickly and confidently. Now you're ready for any kind of fraction comparison. Mixed numbers, improper fractions, weird denominators, you can compare them all. You've got a toolbox of strategies. And the best part? You get to choose the ones that work for you. In my mathematical world, I have one little problem. Professionals, the grown-ups with jobs and coffee addictions, have to compare numbers all the time. Turns out, fractions don't get a free pass. They're just another kind of number that needs sorting, measuring, and decision-making. I've rounded up some fractional dilemmas from the real world of professionals. Can you lend a hand and help them out? During a training session, firefighter Mike drank 2/5 of a bottle of water. Firefighter Dana drank 2/3 of a similar bottle. Write a true math statement to compare the fractions. Who drank more water? Firefighter Mike completed 7/10 of the course in 2 minutes the first time. He completed 5/6 of the course in 2 minutes the second time. Write a true math statement to compare the fractions. When did he complete more of the course? Seiko, a flight attendant, used 1 1/3 trays of snacks on one aisle. She used 4/3 trays on the other aisle. Write a true math statement to compare the fractions. When did Seiko use more snacks? During her pre-flight safety check from Atlanta to New York, Seiko noted that the plane was 4/5 full. On the return flight, the plane was 2/5 full. Write a true math statement to compare the fractions. When was the plane more full? A contractor measured a wooden plank that is 3/4 of a yard long. Another plank is 5/6 of a yard. Which plank is longer? One wall is painted with 1.5 coats of paint, while another wall has 8/5 coats. Which wall has more coats of paint? A patient walked 3/5 of a mile during physical therapy. Another patient walked 2/3 of a mile. Who walked further? During a stretching session, one patient held a stretch for 1 1/4 minutes, and another held a stretch for 5/4 minutes. Who held the stretch longer? Claudia, a police officer, spent 3/4 of an hour on patrol in one neighborhood and 5/6 of an hour in another. In which neighborhood did she spend more time? Claudia completed 7/8 of her case files on Monday and 7/10 on Tuesday. On which day did she complete more case files? Kayla, a candle maker, used 3/4 of a pound of wax for one batch and 2/6 of a pound for another. Which batch used more wax? On Monday, Kayla filled 5 1/2 boxes of candles. She filled 5 half boxes on Tuesday. On which day did she pack more boxes? Kurt, a wildlife officer, tracked a deer for 3/4 of a mile in one area and 3/8 of a mile in another. In which area did the officer track farther? Kurt spent 2 2/3 hours checking traps and 8/3 hours planting trees. Which task took more time? Take a look and you will see a mathematical world around you filled with comparisons. Remember, comparing fractions isn't just about numbers. It's about thinking flexibly, using models, and picking the strategy that makes sense. You've got this. Keep practicing and have fun with math.